In this video, we're going to take a look at interacting with Live's API directly from a MIDI controller. In Live, we have two ways of interacting with the API. We can use a control surface script, otherwise known as a MIDI remote script, or Max for Live. Now, many people automatically default to using Max for Live because of some perceived complexity about creating control surface scripts. However, in many cases, that's just due to misunderstandings. As an example, you might think that there's no documentation regarding control surface scripts. But the LOM documentation supplied for Max for Live actually applies to control surface scripts too. So we do in fact have documentation there. And there's other ways of getting documentation as well. So what I'd like to do here is do a little bit of a comparison. We'll implement the same functionality in a control surface script and in a Max for Live device, so you can see for yourself if control surface scripts are really that much more complicated. Before we get started, I want to point out that this video is not a tutorial for creating control surface scripts or Max for Live devices. We're only going to look at what's involved in both cases for the sake of comparison. For this video, I'll be using the Launchpad Mini, but the functionality we'll be developing will work with any MIDI controller. The functionality that we'll be implementing here is relatively basic toggle functionality, but it's a good representation of what's involved in interacting with the API. So what we'll be doing is setting up some functionality for toggling quantization values. This will allow us to toggle quantization between its current value and none. With this first button, I can toggle global quantization between 1 bar and none. If I change this to 8 bars, now it'll toggle between 8 bars and none. Also, the button's LED will show the state of global quantization anytime it changes. The second button here does the same thing, but for record quantization. Before I get to implementing functionality, I like to write some pseudocode. And this basically looks a little bit like code. It doesn't actually work. It just allows us to see the logic that we'll need to implement the functionality. So it's sort of like a blueprint. So for this pseudocode, we're just going to focus on the global quantization handling. The record quantization handling is essentially the same, so it'll use the same logic. This functionality actually consists of two pieces of functionality. We have the press handling, where we'll toggle the quantization value, and then the LED handling, which will update the LED to reflect the state of the quantization. So even though these work in conjunction with each other, these are really separate pieces of functionality. Now, if we look at the LOM documentation, global quantization is called clip trigger quantization, and these are the values it could be set to. So when it's off or set to none, the value will be 0. Understanding that, we can now write the pseudocode. And for this, I'm going to abbreviate global quantization to just GQ. So for the press handling, if GQ is 0, we're going to turn it on. But to what value? We'll come back to that in just a minute. If GQ is not 0, we're going to turn it off. And that's simple, we just say GQ equals 0. So now let's address this question. Well, we want to turn it on to the last value. So for that, we're going to need a variable to store the last value. We'll call that last GQ value, and I'll initialize it with a value of 0. Now, before we turn it off, we're going to store the current value in that variable. And then when we turn it on, we'll simply set GQ to that value that we stored. So that looks good, but there's actually a subtle bug here. If you want to play along, pause the video here and see if you could figure out what the bug is. So I initialized the variable to have a value of 0. Well, if global quantization is turned off before we turn it on for the first time, our last global quantization value is going to be 0. In other words, we'll never be able to turn it on this way. So we need to give this variable a better default value. Live itself uses 1 bar as the default value, so let's go with that. And that's represented by the number 4. The LED handling is going to be similar. If GQ is 0, we'll turn the LED off. Otherwise, we'll turn the LED on. So there's our pseudocode. Now let's get to implementing it, starting with the control surface script. First, we need to create a folder for the script in Live's MIDI remote scripts directory. I'll call this my cool script. Now I'll move to my editor, which is Aptana Studio, by the way, and create a new file called GQ Toddler. This will handle toggling the global quantization value. And here I'm just adding some setup code, which you really don't need to worry about for right now. And with that all in place, now we can implement our functionality. So going back to the pseudocode, we need a variable to store the last GQ value. And now we'll handle the toggling, which will be triggered by a button. So I'll set up a listener or observer for the value of the button. And this will be called anytime the button sends a value. We only want to do the toggling when the button is pressed, not when it's released. So first we'll check that the value is not 0. Then we need to get the current global quantization value. By the way, self-song is the same as live set in the LOM documentation. If the current value is 0, we're going to set global quantization to the last value that we stored. Otherwise, we're going to store the current value in our variable and set global quantization to none. So this looks very much like the pseudocode. All right. Now we need to set up the button that we'll be observing. So I'll create a variable for that. And I'll need to write some cleanup code to clean up that button variable when we're done using this object, and then write a method to tell this object what button to use. We'll store the button we were given in our button variable and connect the button to its listener. So there's all the functionality. Now we need to wire it up. And you do that in the main file of the control surface script. That'll typically have the same name as the folder. So I'll call this my cool script. And here we have some setup code, which you don't need to worry about for now. And then basically we'll create some objects and then connect them together. The first object we need is a button, which will represent a physical button on the launch pad. The physical button sends a note on channel 1 and its note number 0. Then we'll create an instance of our GQ toggler object, and then we'll connect the two. So we'll set the toggle button of the GQ toggler to be our GQ button. And just one last thing to do, and that is to tell Live how to create an instance of this script. So we'll do that in this file, and Live will call this function called createInstance, and we'll give it back an instance of myCoolScript. With all that in place, we can now select myCoolScript as a control surface, and select the Launchpad Mini as the input and output. And now let's see if that functionality works. Perfect, now let's move on to the LED handling. Here again is the pseudocode for that, and it's very simple. So we'll add a listener here that'll be called anytime the global quantization value changes. And we'll have this first check that there's a button, because if there's no button, there's nothing for this to do. Then we need to get the current value, which is the same as how we did it in the previous listener. And then we'll send a value to the button. The value that we'll send is 127 to turn the LED on if the current value is not 0. Otherwise, we'll send 0 to turn the LED off if the current value is 0. Then we need to wire up this listener. It's going to listen to self-song. And finally, we need to call the listener so that the LED gets updated when we set the button. Great, but this is kind of limited. The Launchpad Mini has multicolored, multi-state LEDs, and we want to be able to make use of those. So these hard-coded LED values are really not ideal. Instead, I'd like to tell this object what LED values to use. So to do that, I'll add two arguments, off LED value and on LED value. And I'll store those in a variable. And then when we send a value to the button, we'll use the values we were passed. What this means here is that if the current value is greater than 0, it's going to use the on LED value. Otherwise, it's going to use the off LED value. Then in the main file, we need to specify the LED values we want to use. For the off value, I'm going to use amber dim, and for the on value, I'm going to use amber bright. All right, so that's all working now. Now let's set up the record quantization toggling. The implementation for that will basically be identical to what we just saw. So we could just copy all this code and create another object called RQToggler for record quantization toggler and make a couple changes to it. But that's not really a great way to go because we need to create a new object for every property we might want to toggle this way. A better approach would be to generalize this object so it could be used with any property. So let's do that. First, I'll rename it to property toggler. We'll rename our variable to last property value. And then we need a few additional arguments. First is the object that contains the property, then the property's name, and then the default property value, which may not be 4 like we have here. I'll store the object and property name in some variables. And then for the last property value, we'll use the default property value that we were given. In the cleanup code, I'll need to clean up the object variable. The way we're handling the property listener with subject slot won't work, so I'll remove this line and rename this method to onPropertyValue. Up here where we're setting up the listener, this is sort of automatic listener handling, and again, this won't work, so we need to do it manually. To do that, I'm going to create a method named removePropertyListener. We don't know what the name of the property is, so we need a generic function to figure that out. That's called getAttr or getAttribute. The first argument is going to be the object, and then the attribute we want is called remove whatever the property name is, listener. And the listener we're going to remove is our onPropertyValue method. And we need to call this method from our cleanup code and also from our setButton method. In this method, we also need to add a listener. All right, and we'll do that using the same code, except instead of remove listener, we'll be adding a listener. All right, now in our toggle functionality, when we want to get the current value of the property, we need to use getAttribute again. And the attribute we want is just the property name. That'll get the current value of the property. Now when we go to set the value of the property, we're going to use setAttr or setAttribute. That's going to look pretty much the same, except it has a third argument to specify the value to send, which is our last property value. And we'll copy this and paste it into the last line where we're setting the property value to 0. All right, and one last change, we need to use the same approach for getting the current value of the property here. Now in our main file, instead of using GQToggler, we're going to use PropertyToggler. Okay, and then we need to specify the object to use, which is going to be self-song, the property, which is clip trigger quantization, and the default value, which is 4. And let's try this out to make sure it still works. Perfect. Now we can just copy these lines to handle the record quantization toggling. If we refer to the LOM documentation, record quantization is called MIDI recording quantization. And as far as the default value, 16th notes, the number 5 is probably a good default. So we'll call this RQ button. It's going to be note number 1, which is the next button on the launch pad. We'll call this RQ toggler. And again, the property name is MIDI recording quantization. The default value is 5. And then for the LED values, we'll use green dim and green bright. And we'll set RQ button to be the toggle button for the RQ toggler. Let's try it out. All right, so that's it. The last thing to do here is, because this code that we just wrote is usable with any control surface script and with any controller, we want to document it to make it easier to reuse in the future. This section is going to go a little bit quicker because we're not going to go through the whole evolution that we did with a control surface script. So for example, we're not going to start off with a GQ toggler and then evolve it into a generalized property toggler. We're just going to start off with the property toggler. The first thing we need to do here is determine how we're going to interact with the controller. Max for Live devices aren't able to directly interact with controllers. They can indirectly interact with controllers in one of 3 ways. The first is through a control surface script. It's possible for Max for Live devices to take ownership of controls from a control surface script and then interact with them. That wouldn't make any sense in this case because if we're going to use a control surface script, we might as well just implement the functionality there. The second possibility is MIDI mapping. Unfortunately, that won't work here because MIDI mapping doesn't allow us to control LED values. So for example, here I've got a Max for Live device with a toggle button. If I map one of my buttons to that button, it'll work, but notice that the LED value simply turns on to amber or off, and we have no control over that. So the only method that's going to work for this is by using a MIDI track to route MIDI data to and from the controller. So for this MIDI track, I'll set the MIDI to and MIDI from to the Launchpad Mini, and I'll set the monitoring state to in. And now I'll insert a Max MIDI effect and get started on implementing this. Now there's many different ways of doing this. Personally, I prefer JavaScript, so that's what we're going to go with here. I'll set up some attributes on the object and then define some variables, just like we did in the control surface script. For the most part, these variables are going to be filled from arguments that we put into the JS object, and we'll add those arguments in just a little bit. For now, we need a variable for the object containing the property, a variable for the property name, one for the last property value, and then things get a little bit different here. We need one for the status byte. The status byte indicates the type of MIDI message, as well as the MIDI channel. Then we need a variable for the note or CC number. And finally, we need a variable to store our live API object in. Now we'll define a bang function to initialize the API object, to point to our object, and the property within that object that we want to control. Next, I'll define an anything function to parse incoming MIDI messages. In case you're not aware, note and CC messages are both 3-byte MIDI messages. That means they contain 3 values. The first is the status byte, next is the note or CC number, and the last is the velocity or value. So here we'll check if the first byte matches our status byte, and the second byte matches our note or CC number. If it does, then we'll process this MIDI message. Again, we only want this toggling to happen when a button is pressed, so we'll make sure the last byte, which is the velocity or value, is not 0. And if it's not, then we'll call toggle property, which is a function we'll implement in just a minute. If the first 2 bytes don't match, we're going to pass the message we received out the second outlet. This is just a minor optimization that allows us to daisy chain these objects together so that each one of them doesn't have to parse every incoming MIDI message. Now I'll implement that toggle property function. And this is going to look the same as our pseudocode and the control surface script code. We're going to get the property's current value. If it's 0, we're going to set the property value to be the last property value that we stored. Otherwise, we're going to store the current value in our variable and set the property value to 0. Now we need to add our arguments. The object will be live set. The property name will be clip trigger quantization. The default value will be 4. The status byte will be 144, which is a note on channel 1. And the note number will be 0. We'll add a live this device to initialize our API object. And then a MIDI in object, which will connect to Thresh. That'll combine our 3-byte MIDI messages into a single message. And now we're good to go. All right, so now let's move on to the LED handling. First, we need to add 2 variables, one for the LED off value and another for the LED on value. I'm also going to define a variable called message header that's going to contain the first 2 bytes of the MIDI message we need to send to the controller, the status byte and the note or CC number. We'll then pass the live API object a callback that'll get called anytime the property value changes, and then we'll implement that callback. First, we need to determine what LED value to send. If the property value is 0, we'll send the LED off value. Otherwise, we'll send the LED on value. And next, we'll send some MIDI messages out the first outlet. The first message is going to be the MIDI message with a 0 value. That'll clear the buffer and clear the LED. And the second message will send out the LED value that we need. Now we'll plug in the LED values, which will be amber dim and amber bright. Then we'll connect this to a from symbol to convert the string we're sending out into a list of numbers that we'll send to MIDI out. All right, let's try that out. Perfect. Now we simply need to duplicate this JS object and put in some different arguments to handle the recording quantization. The property name will be MIDI recording quantization. The default value will be 5. The note number will be 1. And the LED values will be green dim and green full. We'll connect that to our load bang and then daisy chain it from the previous object, and we're all set. And lastly, since this is reusable code that we can use in any Max for Live device, we'll comment this to make it easier to use in the future. The point here was simply to show you that the involved complexities are really not that different. So use whichever approach is more comfortable for you and that makes sense for your particular needs.